Right triangle trigonometry. Objectives. Use right triangles to evaluate trigonometric functions. Find function values for 30 degrees, pi over 6, 45 degrees, pi over 4, and 60 degrees, pi over 3. Use cofunctions of complementary angles. Use the definitions of trigonometric functions of any angle. Use right triangle trigonometry to solve applied problems. Using right triangles to evaluate trigonometric functions. The figure shows a point on the unit circle of radius 1. If you drop a vertical line segment from that point, xy, to the x-axis, you get a right triangle whose vertical side has length y and the horizontal side has length x. The sine of that angle t is y divided by 1. Cosine of t is x divided by 1, and tangent of t is y divided by x. These ratios still apply when no unit circle is involved and when the triangle is not in standard position and is not being graphed using xy coordinates. To be able to use these ratios freely, we will give the sides more general names. The adjacent side is the side closest to the angle. The opposite side is across from the angle. The hypotenuse is the side opposite the right angle. In this diagram, we have angle T, and the side opposite it is over here. The side adjacent to it helps make up that angle, and the hypotenuse is always across from the right angle. Now, if we had said angle alpha, then the side that is adjacent to alpha would be this side. The side opposite alpha would be this side, and the hypotenuse is still the hypotenuse. Now the ratios for sine, cosine, and tangent of t can be represented as sine of t is the opposite side divided by the hypotenuse. Cosine of t is the adjacent side divided by the hypotenuse, and tangent t is the opposite side divided by the adjacent. You can remember this acronym SOHCAHTOA to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There are many different sayings to help you to remember this. One of them is some old hogs came around here tasting our apples, or you can simply remember SOHCAHTOA. Given the triangle, find the value of sine t, cosine t, and tangent t. We identify the angle t is in this position. Sine is the opposite side of 7 being divided by the hypotenuse of 25. So sine of t is 7/25. Cosine of t is the adjacent side. It's the leg that helps make the angle. That's not the hypotenuse. It's a leg. So it's 24 over the hypotenuse, still 25. So the cosine of t is 24/25. And the tangent of t is going to be opposite over adjacent. So the tangent of t is 7/24. Reciprocal functions. In addition to sine, cosine, and tangent, there are three more functions. These functions are the reciprocals of the first three functions. Cosecant of t is 1 over the sine of t. It ends up being the hypotenuse divided by opposite side. Secant of t is the reciprocal of cosine t. So that's the hypotenuse divided by the adjacent. Cotangent is the reciprocal of tangent t. So that is the adjacent side divided by the opposite side. Find the values of the 6 trigonometric functions for the angle t in the triangle. We can use SO, CA, TOA to get the sine of t, cosine t, and the tangent of t. Sine of t is opposite divided by hypotenuse. So 33 divided by 65. Cosine of t is adjacent divided by hypotenuse. So that is 56 divided by 65. And tangent is going to be opposite divided by adjacent. So it's 33 over 56. Now cosecant of t is simply the reciprocal of sine of t. Secant of t is the reciprocal of cosine t. And cotangent t is the reciprocal of tangent t. Finding trig functions of special angles using side lengths. Suppose we have a 30, 60, 90 triangle or a 45, 45, 90 triangle. Remember, we're not necessarily on the unit circle anymore. So this is some measurement other than 1. That measurement is always going to be twice the horizontal measurement if we have a 60-degree angle. And this vertical measurement is always going to be square root of 3 times whatever measurement was here. So let's say that the side S was 3, then this measurement will be 3 square roots of 3, and this measurement will be 2 times 3, or 6. And we can do the same thing with a 30-degree angle. If we have a 30-degree angle, then the side opposite, whatever measure that is, this means that this other leg will be square root of 3 times S, and the hypotenuse will be 2 times S. If we have a 45, 45, 90 triangle, then whatever size this side is, those are going to be equal, and this one, hypotenuse will always be the square root of 2 times whatever the size of the legs are. So let's say if this S was 5, then this would also be 5, and the hypotenuse would be 5 times the square root of 2. So let's find the exact value of the trigonometric functions of pi over 4 using side lengths, as we just did in the special triangles. The sine of t is going to be sine of pi over 4, and we know that to be the square root of 2 over 2. And the cosine is going to be the same as the sine because we're in a 45, 45, 90 triangle. Tangent is going to be 1. Cosecant is going to be 2 over the square root of 2. And if we go ahead and rationalize that, multiplying by the square root of 2 over the square root of 2, I get 2 square roots of 2 over 2, which is simply the square root of 2. And I know the secant will be the same as that. The cotangent is also 1. Using equal cofunction complements. Here's an interesting relationship. Find the sine and cosine of the angles pi over 3 and pi over 6. And do you notice a pattern? The sine of pi over 3 is going to be the square root of 3 over 2. The cosine of pi over 3 is 1/2. Remembering this just from the unit circle. If I have the sine of pi over 6, that's 1/2, and the cosine of pi over 6 is the square root of 3 over 2. So we can see pi over 3 and pi over 6 are complementary angles. They add up to be 90 degrees or pi over 2 radians. And then we notice that sine of pi over 3 and cosine of pi over 6 are the same. The cosine of pi over 3 and the sine of pi over 6 are also the same. If any two angles are complementary, the sine of one is the cosine of the other, and vice versa. Sine of t is the cosine of pi over 2 minus t, or 90 degrees minus t if we're working in degrees. Cosine of t is the sine of the complement. The tangent of t is the cotangent of the complement. Cosecant of t is the secant of the complement. Secant of t is the cosecant of the complement, and cotangent of t is the tangent of the complement. If cosecant of pi over 6 is 2, find the secant of pi over 3. Well, I know the secant of pi over 3 is going to be equal to the cosecant of pi over 2 minus pi over 3, which is the cosecant of 3 pi over 6 minus 2 pi over 6, which is the cosecant of pi over 6. And I know the pi over 6, the cosecant of pi over 6 is 2. So the secant of pi over 3 is the cosecant of pi over 6. And we can do that without all this work in the middle by knowing that pi over 3 and pi over 6 are complementary angles. And so the secant of pi over 3 is going to equal the cosecant of pi over 6, which here is 2. Using trigonometric functions. A right triangle has one angle of pi over 3 and a hypotenuse of 20. Find the unknown sides and angle of the triangle. So here we have a right triangle. And one of the angles is pi over 3. Of course, we have this right angle. I know here I'll have a pi over 6 as my angle. And the hypotenuse is 20. We're to find the unknown sides and angle of the triangle. Before now, we would have just used Pythagorean theorem, but we have to have a couple of the sides to be able to do that, or at least some information to know that these sides are equal, and we don't have that information. In fact, that's not the case here. So we have to use some of our trig functions. How about we take the sine of pi over 3 and we set that equal to the opposite, which I will call x, over the hypotenuse, which is 20. When I solve for x, x is 20 times the sine of pi over 3. And I can use my calculator to put this in. The calculator is in radian mode, so we'll put 20 times the sine, going into the trig menu, sine of pi over 3. And I get an approximate answer there. My exact answer is 20 times the square root of 3 over 2, which is 10 square roots of 3. And the approximate answer from the calculator, I get a 17.3. Now finding the other side, we'll call this y, I'm going to go ahead and take, let's say that we take the sine of pi over 6. That way we're not figuring things off of some rounded number here, but we have the sine of pi over 6 is the opposite over the hypotenuse. So 20 times the sine of pi over 6 is y. This means y is 20 times the sine of pi over 6 is 1/2. So I end up with 10. And it's always good to go back here and include your measurements. My x was 10 square roots of 3, or approximately 17.3, and y is 10. Find x correct to 2 decimal places, and need to note that this sketch is not to scale. So I'm looking at this, I need to figure out what the measurement of x is. So to get there, let's find what this measurement is. I'm going to call this y. Now I have this angle, and I have this side, and I need this side. In relation to that 69-degree angle, this is opposite, and this is adjacent. So that would be our tangent function. We're going to take the tangent of 69 degrees. I know that is 118 divided by y. I multiply both sides by y and divide by tangent of 69 degrees. I'll have 118 divided by tangent 69 degrees. And let's put this into the calculator and get an approximation. So here I'm in radian mode. I need to make sure to switch to degree mode. Just make it a habit of double checking what mode you're in. I have 118 divided by the tangent of 69 degrees, and I get about 45.30. So to 2 decimal places, about 45.30. Remember, this is not exactly what we're looking for yet. We're using this to get where we want to go. Right now, I have this whole measurement is x plus 45.3. And I also have this 29-degree angle. So I can use my tangent function again. The tangent of 29 degrees is equal to opposite over adjacent. Adjacent is that entire x plus 45.3. Now I multiply both sides by x plus 45.3 and divide by tangent of 29 degrees. I'll have x plus 45.3 equals 118 divided by tangent 29 degrees. Now I just need to subtract 45.3 from both sides, and we'll put this into the calculator. So I'm going to input 118 divided by the tangent of 29 degrees, and I'm going to subtract that 45.3, which was actually 118 divided by the tangent of 69 degrees. That way I have as little round off error as possible, and I get approximately 167.58. And remember, if there is some kind of a unit, you'll want to include that unit to be able to get a correct answer on this. Using right triangle trigonometry to solve applied problems. An angle of elevation of an object above an observer relative to the observer is the angle between the horizontal line of sight and the line from the observer's eye to the object. So this would be that angle of elevation. The angle of depression of an object would be if we were looking from the top of that object. It's the angle between the horizontal line of sight from up here and the line from the observer's eye to the object as well. So with those definitions in mind, let's try this problem. How long of a ladder is needed to reach a windowsill 50 feet above the ground if the ladder rests against the building, making up an angle of 5 pi over 12 with the ground? Let's round to the nearest foot. So it always helps to come up with some kind of a picture. So I have some building here, and here's the window, and I have a ladder that is leaning against it. The windowsill is 50 feet above the ground, and the angle right here, this angle of elevation, is 5 pi over 12. And what is it that we need to find? We need to find this length, the length of the ladder, the length of the hypotenuse. Now, in relation to the angle 5 pi over 12, we have the opposite and we need the hypotenuse. So the trig function that involves those is going to be sine. The sine of 5 pi over 12 is equal to 50 divided by x. And again, if I multiply by x and divide by sine of 5 pi over 12, I get x equals 50 divided by sine of 5 pi over 12. And we're going to put this into the calculator. 5 pi over 12 is not one of our special angles. So here I'm going to make sure and change my mode. We're in radians right now. And I have 50 divided by the sine of 5 pi over 12. And we'll get approximately 52 feet if we would round to the nearest foot. From a 200-foot tall building, the angle of depression to sight the end of the block is 29 degrees. How far is the end of the block from the base of the building? So let's go ahead and draw a quick picture. I have this 200-foot tall building. So we'll label this as 200. And there's somebody there at the top of the building looking to the end of the block. Okay, so they see this end of the block down here, and they estimate that the angle of depression here, the angle of depression from the horizontal line of sight to the line between the observer's eye and the object, is 29 degrees. And we need to figure out what this measurement is. We'll just call it X. Okay, if I know that this is 29 degrees, then this is the complement of that angle. So 90 minus 29 degrees is going to give me 61 degrees. Now, in relation to that angle, I need the opposite side, and I have the adjacent side. So we're looking at the tangent function to find that. Tangent of 61 degrees is opposite over adjacent. Multiplying both sides by 200, I get 200 times the tangent of 61 degrees equals X. And we'll put this into our calculator since 61 degrees is not one of our special angles. And again, I need to change my mode to degree mode. I have 200 times the tangent of 61 degrees. And we get about 361. So X is about 361 feet. So the end of the block is 361 feet away from the base of that building. In this problem, I have a cell phone tower that's located 325 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 38 degrees, and the angle of depression to the bottom of the tower is 37 degrees. So how tall is the tower? Again, let's go ahead and draw a picture. We have some window in some building here, and they look up to the top of this tower, and they see they have an angle of elevation. They have an angle of elevation of 38 degrees. And if they would sight the bottom of the tower, then that angle of depression is 37 degrees. Now, I know the building is here 325 feet from that tower. So I know that this is also 325 feet. So I have here two triangles to solve. I need to first find this measurement. We can call that one A, and this measurement, we can call this one B. Again, this is not to scale, it's just a diagram so you can lay down the figures that you have. All right, well, I know that I have this 325, and I need this side in relation to 38 degrees. This is opposite, this is adjacent. So we're looking at using the tangent function. The tangent of 38 degrees is A over 325. And I multiply both sides by 325. I get 325 tangent of 38 degrees. And that's not one of our special angles, so we'll go ahead and use our calculator. double check we're in degree mode. So I can go ahead and take 325 and multiply that by the tangent of 38 degrees, and I get 254 about. So A is approximately 254. Okay, so A is 254, and we'll do that again to find B. So here I have the tangent of 37 degrees is the opposite over the adjacent. And I go ahead and multiply by 325 again. So 325 times the tangent of 37 degrees is B. So 325 times the tangent of 37, and I get approximately 245. So now I need to add A and B to get my full measurement, which is the height of that tower. So I'll just take the values that I have in the calculator and add them. That way we're minimizing our round off error. And I get approximately, we'll say, approximately 499 feet.